is very much essential. Uh, if you have any important building, office buildings, or modern residential complexes, commercial buildings, so we cannot just depend upon supply from the utility. If the power failure is there, so it may not be good situation. So we need to have the diesel generator generally as the standby or backup generator. And the another application we can find the diesel generator in the hybrid power systems. So a hybrid power system, it can be isolated power system, or it can be connected with the grid supply. So in that case, like a isolated hybrid power system in which diesel in parallel with wind, photovoltaic systems, or some other natural resources. So we will have that. So hybrid power system, I will speak on the last day, but here just to keep the same schedule as per our plan, I'll briefly touch upon the diesel generator, and then more we will discuss about the diesel generator when we are talking about the hybrid power system. Then in second session, second lecture, uh, I'll speak about the photovoltaic systems. So this before we talk about the photovoltaic system, I will speak about the current trends for the power generation. Yesterday we talked about the conventional power systems. So modern trend is to generate power through renewable distributed generation. We'll speak about the distributed generation connection requirements and what are the important DG technologies. So very important DG technologies are, of course, photovoltaic systems and wind power systems. So today we speak about the photovoltaic system, and then tomorrow we talk about the wind power system. So regarding the diesel generator, first of all, when we have to decide the diesel generator for any buildings, it can be residential apartments, it can be office building, uh, multi-story buildings, or you can have the commercial, uh, uh, shopping complexes. So uh, selecting or deciding the diesel generator sets. So first of all, you have to see the requirement. What is the requirement? Which kind of requirement is there? You can have a special kind of building. Just to give you example, for example, uh, buildings used for um, the transmission, Doordarshan or All India Radio. So that may have kind of special requirement, because if the power goes for the when the transmission is taking place on the TV, so you will not expect that there is power failure. Okay, so in that case, the requirement would be that diesel, if the normal power supply goes, diesel generator should able to open and start within few seconds, because we do not want to see the failure of power transmission during the transmission. So their requirement would be that uh, power supply should be restored as soon as possible. Okay, so first of all, like we may need to decide what kind of building is there for which we are designing the diesel generators. So here, you know that what is the diesel generator. So diesel generator along with generator. So combined set, we call it DG set. It's comprised of diesel engine and generator. So here diesel diesel engine will act as the primer for the generator. So this generator will be generally the synchronous generator. So both will be coupled on the same shaft. So here diesel fuel will run the diesel engine, and it will convert the mechanical energy into electrical energy in the generator. Now, how these diesel generators can be classified, categorized? They can be categorized by the different ways: types of fuels, types of engine, its speed, the form of aspiration, operating cycles, etc. Okay. So the mechanical engineers can know more about these sort of things. Types of fuel can be type 2 diesel oil light, or can be crude oil heavy, and it will depend upon, when we are installing the diesel generators. So we have to think in terms of uh, uh, which kind of oil will be there, how it will be made continuously available. The choice will, of course, depend upon the cost, availability, its calorific value, temperature conditions, specific engine features. So basically, we have to give consideration to the number of points. So here, when we talk about the DG technology, diesel generator technology, so it is well proven technology. We have been generating electricity in the small scale through the diesel generators, maybe uh, you know 50 years or 100 years. So basically, it is well proven technology. So power can be produced without any issue. But there are some issues in terms of that the power produced is extremely costly because of the cost of fuel, then transportation and heavy maintenance. So transportation, think of the situation if the diesel generators are like in some island countries. So transportation cost will be significant, and the maintenance cost will be significant. So power produced will be very much significant. Now, when we are deciding the uh, size of the diesel generator, I'll speak more about the sizing, but you can see that diesel generator can be naturally aspirated, or it can be turbocharged. Okay, so in naturally aspirated, basically air is taken at the atmospheric pressure, whereas in turbocharged, air fuel mix is at higher than the atmospheric pressure, which can increase the engine efficiency. Now, the operating cycle for diesel generator can be two-stroke or four-stroke engine. So here two-stroke, basically, like for the small uh, systems, for example scooter, it has got the two-stroke engine. Whereas if you consider like the large systems like the cars, buses, or large engines, so obviously it will be four strokes. So strokes means that you have four cycles: suction, compression, expansion, and exhaust. In two-stroke, two cycles, suction and compression, are completed in uh, one stroke, and then expansion and exhaust are completed in another stroke. Whereas in four stroke, we have just only one operation, like in one strokes only suction, then second one compression, third one expansion, and finally the exhaust. Okay, so obviously these four stroke diesel engines are more uh, uh, advantageous. They have better efficiency. Now we have to see the uh, important aspect is, of course, the cooling arrangement. Cooling arrangement for the diesel engine is very important. So this, if there is small size diesel engine, so they can be natural cooled. But if it is a large size diesel engine, so it will be obviously forced cooling by means of some fan, exhaust fan, or it can be liquid cooled. Now, engines can also be classified, categorized based on the speed of the engine. Like the larger engine generally will operate at the lower speed, whereas high speed uh, engines will have, you know, speed. So basically, the speed can also be one of the criteria to classify the diesel engine. Now, what are the controls or what parameters we are required to control for the diesel engine? Now, the diesel engine, like how much control associated with the diesel engine? Simply, it will depend upon, of course, size of the diesel engine. If you have, very small size diesel engine, maybe very small size, so it may not have, very complex or uh, large control system associated with that. But if you have got this significant size of diesel generator, for example 500 kilowatt or larger size, then obviously there will be significant controls associated with the diesel generator, because the cost of these uh, control systems can be easily justified. So here basically we have this diesel generator. So we are talking about slightly large size of diesel generator. Basically, two important parameters, as I mentioned yesterday as well, that we have to control is voltage and frequency. So this frequency, obviously we would like to maintain close to 50 hertz, because generally this is the frequency at which system will operate. So this frequency will be associated with the fuel input to the diesel generator. So basically there is governor mechanism in all type of generator. You can have mechanical type of governor, but in modern generator you will have obviously electronic governor system, which will basically control the speed and relate with the frequency of the diesel generator. The another control associated with the diesel generator is, of course, the voltage control, and that voltage control will be taking place in the synchronous generator connected on the same shaft of the diesel generator. So excitation system will basically control the voltage. Okay. So by changing the excitation current of the generator, it will control the voltage. So these two important controls are there. There will be, if you see the large size of diesel generator, if you go in the diesel generator room, so you can see that all these controls will be associated with that. But if you got like very small generator, then not necessarily all these control systems will be there. So the control system will be very simplified. Now, if you are deciding, in fact, this I will speak more, or if you are deciding the rating for the diesel generator. So here you can see slide bit more clearly about the real power and reactive power that we talked something yesterday, and some participant asked the question, what is this reactive power as well. So here you can see that basically we have basically three types of power. One we call as the real power or active power. Its units are watt, kilowatt, megawatt, or very big system, gigawatt. Same way, reactive power, its smaller units is volt, ampere, reactive, VAR, or if it is bigger size, then we call it kVAR, MVAR, etc. Then we have basically the another power which we call as the apparent power, denoted by S. So this S will be basically equal to P plus JQ. If you make one right angle triangle, on the base side is your real power, perpendicular is your reactive power, because reactive power is your what we call as the imaginary power, and the diagonal part is your apparent power. So this apparent power S is basically your real power P plus J times of Q. The unit for apparent power is kVA, MVA, etc. Okay. Now, if you have to decide the rating of diesel generator set, how you will decide the rating of the diesel generator? As I mentioned, if you have any electrical machine, can be transformer, diesel generator, or synchronous generator. So its power rating would be generally specified in terms of apparent power, which will be equal to real power plus reactive power, P plus JQ. Now, you can vary how much real power and how much real reactive power you want to obtain from the diesel generator. So basically, apparent power is combination of P plus JQ. If we talk, for example, using this diesel generator, say in the hybrid power system, which may comprising of, for example, diesel generator plus your wind system is there. So if you have to decide the real and reactive power for the diesel generator, a hybrid power system, I will explain more on the last day as well. So here in the system, you have got the diesel generator, then you have got the wind power system, then there can be some dump load in the hybrid power system. Why this dump load is required? If you have this a hybrid power system in which you have the wind, for example, and diesel. If excess power is being generated from the wind system, then where this power, excess power will be utilized. Okay, so the excess power can be just dumped into the dump load, because we have to maintain a balance between the real power generation and demand in real-time system to maintain the frequency. So if real power is being generated by the wind system, we have to utilize it. If there is some useful means in terms of like space heating or some application, we can do that. If not, then we have to simply dump the excess reactive power in the dump loads. So dump load is integral part of the hybrid power system. Same way is the case for the reactive power rating of the diesel generator. So it will depend upon the reactive power rating of the load, that your load can be inductive load, induction motor loads. So how much reactive power it is required. Then if your dump load is comprising of the inductive load, so it's the reactive power rating. The wind system, if wind system is operating on the induction generator, I will speak more on the last day. So how much reactive power will be taken by the wind system induction generator? So you have to consider that as well. Okay. Here on the upper equation, we consider minus here, because how much will be the rating for the active power rating for the diesel generator? You have this reactive power consumption by the load, sorry, active power consumption by the load, active power consumption by the dump load. But you have the wind system. Obviously, wind system will supply the power, active power. So this will be the rating for the diesel system. So I just briefly explain explain if you have to decide the rating for the diesel generator. Now, I will give you the reference if someone is more interested about the designing of wind diesel power system. I will provide the reference for the book in which someone is interested to know more about the rating for the diesel generator. Then, of course, the power factor of the system. You have to consider the power factor of the systems. So accordingly, based on the power factor, you uh, calculate the angles and accordingly find the apparent power rating. So as I mentioned, the apparent power rating of the diesel generator is basically equal to P plus JQ, or it will be equal to P D square plus QD square, where D stands for the diesel. So that will be decided by the rating of the diesel generator. Now, what is your specific power factor of the system? Accordingly, you can decide the rating of the diesel generator. I'm not going into the detailed mathematical equations of that. So here I just give you very brief about the diesel generator, and we'll talk more about the diesel generator, its application for the hybrid power system on the last day. Now let us speak about the current trends for the power generation. What is the current trend for the generation of electricity? Of course, as I mentioned yesterday, we are generating electricity through the conventional power system, coal-based, large hydro, nuclear, etc. These sources will continue. The issues with the coal-based systems are, you saw that the lot of emissions. So that is not the preferred way, but we do not have the options. Uh, so still we have to keep on generating. But what is our choice? What is the current trend? So current trend is to generate power through the renewable distributed generation. So what are the distributed generation? So there are the small generators, renewable distributed generators like the wind systems, photovoltaic systems. So generally they are in the small scale. They are integrated. If they are small size, they are integrated in the distribution system. But if these are the significant capacity, they can be integrated in the sub-transmission or transmission network. In the past, we had been generating electricity through the large scale generators, and we had been going for the larger and larger size of generator. The large size of generators can be 500 megawatt, 1000 megawatt, even up to single generator can be 2000 megawatt. Okay, so because economy to the scale is associated, if you have the large size generator, obviously power produced will be uh, economical. And this is like, in general, we can simply understand, taking any simple practical example. If you have, Coke, one, you know, one 300 ml or one two 2 liter bottle. So obviously economy is associated to go for the uh, large large size. Okay, so same principle was also there in using the large size of generator. But going for the larger and larger size of generators, there are some issues as well. One of the issues, if there is very large size generators, if the generators fails, whatever reason it can be, so the how the reliability of the overall system will be affected. Professor Saket is expert on the reliability. He will speak more about that. So the reliability of the system, then you have to have a kind of backup system for that size of generator. So the reliability of the large system can be a concept. concern. But in the current time, what is the modern approach? So the modern approach is to generate the electricity in the smaller renewable distributed generators close to the load centers. So with this type of generators, because the loads are very close to the generators, the distance is almost minimized in can be few kilometers. So we know that transmission and distribution losses are basically proportional to the length of the transmission line. So length is almost reduced to 0. So these transmission and distribution losses are significantly reduced. One of the major issue what we see in our Indian power systems particularly, that we have got the huge transmission and distribution losses. Can have 20%, 25%. Few years earlier, some states can have 30%, 40%. So this is huge transmission and distribution losses. If we have this very high, huge transmission and distribution loss, any amount of uh, capacity addition we have, still there can be shortage of power. Okay, so it is very much essential that we reduce the transmission and distribution losses. So these renewable distributed generation, they can play a big role in reduction of the transmission and distribution losses. Another major issues what we had been seeing in the conventional power system was the emissions. So this issue can overcome. um, it can help in reducing the emission because this wind PV, these are green technology. They have the positive impact on the environment. So these are the two key benefits I listed, but there can be several other technical benefits if the diesel generators are properly sized and placed at proper locations. So they can have several technical benefits in the academic research, different application of the distributed generations, location sizing, reduction of the losses, improvement of the voltage. So a lot of research has been conducted. So this DG can offer large number of benefits. But when we have this distributed generation, there are some technical challenges, okay, which engineers have to overcome. What are these issues, technical challenge? Generally, these renewables, they are fluctuating in nature and these are intermittent. So what is this fluctuating and intermittent? Like we have the wind at one instant, next instant there is no wind. Okay, so wind is highly fluctuating. So wind can fluctuate. Same is the case for the photovoltaic system. We have the PV shining is there. Cloud comes, then there is no sunshine. During night, there is no sunshine. So basically, these renewables, wind, PV, these are fluctuating and intermittent in nature. Now, the another challenge we have got that our power system networks were designed, constructed 100 years earlier. At that time, no one gave a thought that at some point of time, renewables will be likely to come. Okay. So the traditional networks have not been designed considering the DG interconnection. Here DG, we are talking for the distributed generation. Previously, we had been talking DG for the diesel generators. Okay. So when we are integrating the distributed generation to the grid, you can see here in the pictures that in the distribution system we are integrating the diesel generators, distributed generation. So with the integration of distributed generation, power flow becomes bidirectional. What is the meaning of bidirectional? All the power electronics people will understand that if you see that in the conventional system, power is flowing from the large generators through transmission network to the load. Power flow is in one direction. But with the integration of distributed generation, power is flowing from the diesel generators through transmission to the load. But if you got the diesel DG in the distribution system, excess power available through this distributed generation can be fed back into the grid. Okay. It means power flow is bidirectional. Okay. So what is the issue with the power flow is bidirectional? The protection is one of the biggest issue, because in the past we had the simple protection system. The single directional relays were used for the protection purpose. But when the power flow becomes bidirectional, so existing protection scheme may not work well. Okay, so we may need to have the significant modification in the existing protection schemes. Either we need to make significant modification, or the protection system may, require the complete replacement. So this protection is one of the big major challenge. Then the traditional network have not been designed for the these intrications, and these are fluctuating and intermittent in nature. Now, when we are integrating the DG to the grid, so there are certain grid code requirements. Okay, so there is one standard IEEE 1547, and then several countries have developed their own grid codes to uh, provide the guidelines for the distributed generation, interconnection to the utility. IPPs will connect their DGs to the grid. So, but they have to follow the certain requirements before these are connected with the grid to maintain the quality of the power supply. Here, some of the requirements can be in terms of fault ride through capability, voltage and frequency operating limits, active power control, reactive power control, other requirements in terms of power quality, protection, etc. Here, what is the fault ride through capability? If the fault occurs on the grid, so how the renewables will behave? Okay. In the past, the approach was that if the fault occurs, these renewable plants will be disconnected from the grid, because maintaining the safety and security of the plant was more important. Okay. But in modern system, these renewables plant will not be immediately disconnected from the grid, but they will stay to the grid, and they will not only just supply the power, but they will try to help in recovering the fault condition, because the control features of this renewables plant has been significantly improved. Okay, so again, as I mentioned, the one of the key requirements are to maintain the active power control, maintain the system frequency, maintain the reactive power control, maintain the voltage. So these two are the extremely important control, the parameters, frequency and voltage, which we have to maintain. Just to give you the example here, you can see that these examples for the two cases. One is for the Denmark, below one is for the China, for the frequency and voltage control. Now here, for the Denmark case, you can see that if the system is under normal operation, the frequency can vary between 49 to 51 Hz. But if the frequency deviates from the normal frequency range of 49 to 51 hertz, then we cannot afford to have this operation for the large duration of time. Okay. Within this specified time, we have to bring back our system to the normal operation. So here it is not only the control, but control has to be very fast. Okay. If the control system is like this, then it can lead to have the disconnection of the renewables from the grid. Okay. So this is another example for the China case. Again, this is the normal operation. We have to maintain the frequency in the normal operation. But if the frequency deviates from this normal operation, then within the specified time, we have to bring the system back to the normal operation. Same is the case for the normal operation of the voltage, that we have to maintain our system in the normal operation of the voltage. Now this I just try to explain few of the requirements. There can be several other requirements in terms of ramp rate, reserve, power quality, protection, etc. Okay, so I briefly explain about the distributed generation, and now let us talk about the photovoltaic system. This photovoltaic system, we call this as the renewable distributed generation. So this is one of the great way of generation of electricity. Here you can see that we have got the huge potential from the photovoltaic system. For example, this earth surface will receive this huge power from the sun, and if you can just tap the power for 1 hour, so this can satisfy the demand for the whole universe for a period of 1 year. Okay. So it means that photovoltaic system has got the huge potential. We may not need any other type of power if we can uh, nicely tap the significant potential from the photovoltaic system. And you can see that the conversion in the PV system is is very nice. Means that there is direct conversion of sunlight into the electricity, no moving parts. Okay, so direct conversion for generation of electricity. If we see, the advantage of PV systems are really great. The PV generation is environment friendly, reliable, having no moving parts, complete silent operation, very low operation and maintenance cost, can be installed very quickly. If you see, for example, other type of plants, coal-based or large hydro, the gestation period can be 5 to 8 years. But here, for the photovoltaic system, gestation period is very small. You can have large size PV plant, less than in a year you can install, and uh, power can be start producing. Okay, so there are large number of benefits associated with the photovoltaic system. Recent past, we used to have one of the issue that the PV system is costly. Power produced from the photovoltaic system is more costly. But now the cost has not become no more an issue. Even the power produced from the photovoltaic system can be less costly than the power produced from the conventional power system. So the cost is no more an issue. Now let us see what are the different types or options for the photovoltaic systems. Okay. So The PV systems can be grid connected, PV system can be isolated. So we are just seeing the different options. If the PV system is grid connected, it can be small residential system, it can be large size system. So what can be the mounting arrangement? If it is small size, PV systems can be mounted on the roof of the buildings. Even you can see for the street lights, there is small PV systems. It can be mounted on the poles, or in some cases, the PV system can be integral part of the building as well. But if you have the large size PV systems, then obviously these PV systems will be placed on the ground. The another option for the PV system can be the stand-alone photovoltaic system. Stand-alone means that this is not connected with the grid. So then photovoltaic systems would require some kind of backup, because in the night there is no power from the PV. During midday, when cloud comes, how the power will be supplied. So backup could be in terms of battery banks. In addition, there can be diesel generator as the backup. So diesel generator may or may not be there, depending uh, upon the kind of standalone systems. So we have to give the consideration for the backup for the standalone or isolated photovoltaic system. Then there can be in standalone, there can be another application uh, which can be used for the water pumping systems in the irrigation system. So here the system is standalone, but it doesn't require any backup. For example, for the irrigation purpose, we have sunshine, it is producing the electricity, and which is being used for the to supply the water. So simply we have the, for example, PV systems, a DC motor is there, uh, and it can be used for the irrigation purpose. In the irrigation system, we are interested in designing the PV systems which should be least costly to be affordable by the farmers. So obviously when we have these backup systems, battery storage system, then cost will will be more increasing, the cost will be increasing. So to reduce this cost, the system is like standalone, no backup system. Whenever there is sunshine, uh, it will start supplying the water, because that application farming, it is not necessary that you have water supply during the day or during the night. So main objective is to have the system less costly. Okay. Obviously, whenever we have the sunshine, it will supply the water and it can be used. Now, let us understand some of the operation of the photovoltaic systems. So we have got the photovoltaic systems, PV systems have got the technical characteristics which we call as the IV characteristics, current versus voltage characteristics. If we see the typical IV IV characteristics of the photovoltaic system, it will be shown like this way. Okay. Now, when we have this PV system, in addition to PV modules, we have the other systems like the load, batteries. We have to see the IV characteristics for the load, battery systems to see that our overall system will be efficient. So here, if we have the load, which can be resistive load or motor load, we have to see what kind of the load characteristic it has got. For example, if the load, we have say the load characteristic something like this way. Now, where the IV characteristic will crossing the IV characteristic of the PV system, that will be the operating point. Okay. We want to operate our PV systems corresponding to neck of the PV system. Corresponding to this point, maximum power will be supplied to the load. So our objective is to operate the load corresponding to the MPP condition or neck point of the IV curve. Okay. Just to explain, for example, if the load is resistive load, purely resistive load, if we have this a variable resistive load, if you want to do is like, for example, simply in the laboratory, we have got one or two PV panels, then we have the variable resistance rheostat. Now, by varying the value of resistance, we can vary the current. So we can have the different these graphs by varying the resistance. Now here the objective is that which line we would select for our operation. So our objective is to operate the system, adjust the load corresponding to neck point of the PV system. Corresponding to this, maximum power will be transferred to the load. So we can easily adjust the load. You can see if the value of R is adjusted corresponding to RM, the current is IM, voltage is VM. Corresponding to that, maximum power will be supplied to the load. So from here, it will give you the concept of MPP condition. Okay. Now here, everyone is aware about this MPPT, maximum power point. So this MPP point is corresponding to this neck point. But here, I would like to mention that in the previous slide, I show that IV characteristic of the PV system is like this way. But as we know that sunshine during the day, it keeps on changing. Okay. So in the morning, you have this less sunshine, then during midday, it is high sunshine. So as the sunshine keeps on changing, so rather than having like one curve, you will have these several curves. Okay. Even for example, corresponding to this characteristic, if you adjusted your load to this MPP condition. But as I mentioned that during the whole day, your load will keep on changing, means your sunshine will keep on changing. So what does it mean? It means that you adjusted corresponding to one curve, but it will keep on changing. So you cannot operate corresponding to MPP condition. So what does it mean? That you cannot manually manage the MPP. So what we have to do? So basically we need a device. Depending upon the application, which can operate our load corresponding to MPPT condition. In the previous slide, I explained about the application of DC motor for the water pumping application. You can have this like the characteristic for the DC motor. As we will see that if you have this any motor, in the starting, it will require the large current. If you can see this graph, basically during the starting, the current requirement will be large. If by some means the motor can be started, if we can have some arrangement, motor can be started, the current can be reduced during starting. So we can start the motor, just to explain you from like this slide, like the how much current will be supplied from the PV system. It will be, you can see here, this is current. So the amount of current from the PV system will depend upon how much is the sunshine. If sunshine is less, so obviously less power generated, less current. If in the early morning you have this power corresponding to say 200 watt per meter square, but say around 8 a.m. so it is 200 watt per meter square. Around 10 a.m. it becomes 400 watt meter square. And then during midday or in the afternoon, there is full power 1000 watt per meter square. So to say start the DC motor, you need say minimum power of like 400 watt per meter square, this much of current during the starting. So the motor, DC motor will start say around 10 a.m. or 11 a.m. in the morning. But if you have some device which can help in starting of the motor with low current, then your motor can be started corresponding to say 8 a.m. early in the morning. It means you can have extended hour of operation for the motor. So basically, you can have a linear current booster. The people who are expert in the power electronics, they will understand what this linear current booster is that. So here you saw that we superimpose the DC motor characteristics on the IV characteristics of the PV systems. Depending upon sunshine during the day, the current keeps on changing. Okay, so the motor will require this much of current during starting, but if we can have some device which can help in starting of the motor, so motor can be started corresponding to say 200 watt per meter square. Motor can be started early in the morning. Once motor started, it keeps on running for the extended number of hours. So motor can supply the water for the significant number of hours. So the performance of the water pumping systems can be enhanced. So here it basically explain you about the concept of the MPPT. Dr. Bhardwaj, let me know when we have to take the short break, or I can continue.
11:15 to 11:30 is the short break time, sir.
So how much time we have for the break?
Only 15 minutes break is in between.
No, break we will have now or after how much time?
10 minutes.
After 10 minutes, okay.
Yeah.
We can have the other devices like these batteries in the PV system. So we need to understand the IV characteristics, IV curves for the battery systems. If we have the ideal batteries, so its IV characteristic is a straight line, because battery will have the internal resistance. We have to consider that, but a practical batteries, its IV characteristic will be slightly different rather than being a straight line. So either the battery is being charged or discharged. Accordingly, the, these curves for the batteries, either it will be tilted on the right or left side. So depending upon whether there is charging or discharging operation, the IV characteristic of the batteries are shown here. Now the MPPT. So this is like extremely important topic for the photovoltaic systems, for the researchers. Large number of researchers do their research around this designing of the MPP system, developing the algorithm for the MPPT. So here, uh, with the MPPT, significant efficiency gain can be realized if the load, which can be resistive DC motor batteries, so if this can be operated corresponding to the knee point of the PV system IV curve during the changing daily conditions. So the device which can do that is called as the MPPT, maximum power tracking system. Okay, so here, what is this MPPT? What kind of circuit it has? So I will show in the next slide one of the example of the MPPT comprising of the circuits simply called as the uh, back and boost converter. So which can raise or lower the voltage depending upon the requirement. So here you can see the example I show you for the DC motor and the PV system. If you have an MPPT, which is a buck and boost converter, so buck and boost converter, it can raise or lower the voltage being applied to the DC motor depending upon the requirement. It can increase the voltage level, it can decrease the voltage level. So you can see it has got just like few components: inductance, capacitance, a diode, and a switch. So this switch is not simple electrical switch, but it is like an electronic switch based on the uh, transistor or IGBT, etc. So here this transistor based on the IGBT or FET, it will flip on and off at very rapid rate of the order of like the frequency 20 kilohertz. Okay, so this switching operation will be very fast. Okay, so here you can see that in the circuit, basically when the switching operation is fast, when the is made on switch is made on, so this circuit is completed, inductor will be charged. Okay, when the made off switch is made off, so the energy stored in the inductor, now this circuit is open, so the energy stored in the inductor will be dissipated in the capacitor. So whatever is the energy stored in the inductor in half cycle or so, that should be dissipated in the next cycle. So how much duration of time this switch is made on and how much duration this switch is made off in one cycle, this is called as the duty cycle. So power electronics people will understand this nicely. So we can adjust the duty cycle of the switch. Okay, so here the main thing is adjusting of the duty cycle appropriately, and that can help either increasing or decreasing the voltage level. So here, what is this duty cycle, duty time? So you can see that in one time period, how much duration this switch is on, how much duration this switch is off. So this is called as the duty cycle. Here you can see that uh, the opening time and closing time of the switch, which is equal. So we say that duty cycle is 0.5. If here you can see the switch which is closed for the larger time and open for the short duration, or we can have the situation when the switch is on for the longer duration and off for the smaller duration. So accordingly, we can adjust the duty cycle of the switch. So of course, as we have seen that when the switch is on, the power will be stored in the inductor. Then during the next half cycle, when the switch is off, so this power dissipated will be discharged in the capacitor. Okay.
Can we interrupt you, Professor?
Yes, please.
One question from our departmental faculty, that what is solar constraint and how to calculate it, and it should be constant at all places across the world.
Okay, so it's a very good question. So the maybe let the Dr. Bhardwaj maybe ask the student question directly, so he or she can speak.
Okay, let me open that.
Yes, sir, that will be nice. So at least we can interact the participant directly. Maybe
I am opening that.
I can see then a nice voice for the participants as well.
Okay.
Good morning, Professor Bansal.
Good morning, Professor Saket. You are looking very nice. Seeing you after a long time.
Yeah.
Professor Ashok, you can ask the question directly to Professor Bansal. Ashok Rajput, sir.
Looks that there is some signal problem.
I think.
सर हमें उनको खोलना पड़ता है, वो ऐसे नहीं पूछ सकता कोई भी क्वेश्चन जब तक हम आवाज आपकी आ रही है।
मैम अलाउ करिए।
हाँ सर, एक मिनट कर रही हूँ।
Professor, after how many months you are planning to come to India?
India now, the situation worldwide is very, problematic because of this COVID situation.
Yeah.
So let us see in few months situation can be normal. Then we have break in July. Vacation in July.
I would like to invite you to come during Magh Mela.
Magh Mela is in March or when?
In January.
Crowded time.
So in Varanasi also the Magh Mela is there, eh?
Yeah, we have always Magh Mela in Varanasi. We don't wait for January.
When it is throughout the year, then we can come anytime.
Yeah. You are most
Magh Mela is throughout the year, not in the Magh month. Eh?
Yeah. You are most welcome to come here.
And so we came for the Magh Mela in Allahabad when Bhardwaj and you were there in Allahabad.
Yeah.
But now you moved to the another holy place in Varanasi.
Yeah.
So hopefully we'll come maybe in July.
So Ashok Rajput is not on the line because.
Okay, no problem. So please repeat the question again, Bhardwaj.
I am repeating you. The question is, Sir, what is solar constant and how to calculate it? And it should be constant at all places across the world.
Yeah, constraint is basically, the solar, the power output from the solar is, of course, from the site specific. Okay. Uh, so site specific means that, how much is the average sun insolation for a particular place. Okay. How much sunshine is there at particular locations, how many hours the sun shining is there. Okay, so generally large number of places have the good number of hours sunshine, typically say 5 hours, 6 hours in a day. So this is the like one of the parameter mainly we need, that how many hour as an average sunshine is there. If there is good sunshine, we can install the PV system. So basically, with the photovoltaic systems, there is great flexibility to install the photovoltaic system. Of course, for the another renewables like wind, it is just only wherever we have got the good windy place. But for the PV system, there is a great flexibility that PV system can be installed large number of places where, of course, there is good sunshine is there. So basically, it will depend upon how many hours as an average the sunshine is there, and then accordingly the power output from the solar can be calculated. I will speak more in the coming slides on that points.
And the next question is how we decide the size and rating of battery for a PV cell. It is from Dr. R.C. Chaurasia.
Okay, maybe this is good question. Maybe let us keep the question maybe for the when we complete the photovoltaic system, then this chapter will come. This topic will be completed. Then things will be more clear.
Right. Correct. So we are having a break of 10 to 15 minutes.
Sure.
We will start after 11:30. Hello,
Okay.
Professor Saket, how are you?
I am 100% okay, Professor. Thank you very much for organizing such a beautiful session.
Professor Narottam Das is also here.
Professor, good afternoon.
Good afternoon. So
how
I'll try to join at 5 o'clock to listen something. Okay. Thank you very much, Professor Bansal. We have correspondence today. We have very good friend long way back. So for that, we have little bit reconnected yesterday, and then I sent an email to him and also communicate. And Professor Saket,
yes,
in a common platform.
Narottam, it was a good time we met in Australia, so it was really a great time.
Yeah, no. It's a very good.
Actually, I got slightly,
and then we have many conferences also attended together.
Yes.
Tasmania, Bali.
There is another one more, Dr. Narottam, maybe Narottam Kumar Roy. Maybe you may know.
Oh yeah, that one was UNSW.
He is now in UNSW or gone back to the Bangalore?
He was with Professor Himanshu Potar.
Yeah, Himanshu Potar.
Yeah.
Okay, good.
Roy. That is
yes,
Roy.
Roy.
I have also good contact with him.
Narottam Kumar Roy.
I also sometimes support him.
I saw that Dr. Narottam is very good colleague of mine. Why he is delaying my paper? Then I realized he is a different Narottam.
So sorry, could you repeat again?
I'm just joking that I thought you are the same Narottam. Then why you are delaying my paper? Then I realized it is different Narottam.
Not the same. Name is same, but person is different.
Yes, I just saw the first name Narottam, Dr. Narottam.
All right, no problem at all. Anyway, thank you very much.
Yes,
Professor Bansal and Professor Saket and Professor Bhardas, we will keep in touch. And then 5 o'clock, right? How long break?
Just only short break, 10 minutes.
Okay, all right, okay.
So break is just for us to keep on chatting, because during during the lecture, Dr. Bhardwaj will not allow us to talk.
Yeah.
So maybe the break is just to have the
Yeah, that's right, because
chat,
that time is official presentation.
Yes.
That's why when we went to conference, eating, chatting,
Yeah. So
discussing many things, connection over
conference
there.
is whenever there is break, so people will meet, talk, just memorize their past time.
Yes, that's right.
So how is Saketji, your family?
Yeah, we are 100% okay, sir.
Very good. So you are staying in very holy place.
Yeah.
Dr. Narottamji, you are from Bangladesh or India?
Bangladesh.
Originally, I'm from Bangladesh. That was East Pakistan actually, then changed the name Bangladesh, but I studied in India 71 and 77.
So which place?
Kolani and Kolkata.
Oh, Kolkata. But now you change the name as well. Calcutta, now Kolkata.
Name changed as Kolikata. They say that is the government policy saying.
Now it is easy for the Bengali people to pronounce.
Yeah, that's right.
We used to have colleague Dr. Biplab Bhattacharya. So you'll say hum chai khaya subah.
Yeah, that's right. Even though the Professor Bansal, it was the same in Bangladesh also. Some places name has changed.
Yes.
Fully Bengali.
So he used to say Bansal hum ghar jata chai kha ke aayega bhi.
I suggested Professor Bharadwaj to contact Professor Bhattacharya, but I don't know why Professor Bhattacharya is not here.
वो अभी चाय खा रहा होगा भाई. वो एक बार इनवाइट किया उधर, तो हम लोग जब ब्रिस्बेन में थे, तो आप नरोत्तम जी हिंदी नहीं समझेंगे अभी, तो you understand slight bit Hindi as well?
Myself?
हाँ.
I know Hindi that time, even I can write, but I forgot everything. That is.
You can understand Hindi, eh?
A little bit, not much.
Okay. So, one conference in 2010, one conference was there in Gold Coast, Brisbane. Can you hear?
Yeah, I can hear.
So then Dr. Biplab Bhattacharya, so he planned to come basically to meet and attend the conference, and he planned. And then, he's a different kind of mood guy, and he said, I was waiting for him. I asked him someone to go to airport and pick him up. And then he did not turn up. And then I tried to inquire what happened. He said, no, हम आ ही नहीं पाया इधर से, पता नहीं हम यहीं चल ही नहीं पाया. चल नहीं पाया, आप तो उधर से मैसेज तो कर दीजिए, उधर कोई एयरपोर्ट पे आपका वेट कर रहे हैं. अभी
so you lost your time, pick up and so on, go to airport.
Saket ji is waiting to join this program, and he may say हमें भी चाय खाता रहा, उधर नहीं आ पाए.
Anyway, I think they should communicate, and then at least to manage the time program and so on. Conference interaction is very important. Certainly. Now we cannot go physically. That's why we are doing at least by Zoom.
In fact, this is, great things which should come out from this unfortunate COVID situation, that even the people who cannot attend physically, whatever reason, so both the provisions should be made in all the conferences. It will reduce the cost and more people can join. So basically it can add more value to the conference.
Yeah. That is also a lesson from COVID, I would say.
Certainly. Yes, definitely. Because people have their constant visa, cost and so many teaching,
yeah.
so many constraints are there.
For example, in you want to go to US, but you don't need visa. Online Zoom is enough.
Certainly, certainly.
So, you know, Professor Bansal, Saeed was my supervisor. This year
Professor
we
Saeed
have the
Islam.
paper at
Professor Saeed Islam Curtin.
yeah. Curtin is now at the Federation. There is problem everywhere. You may know about this Australian trend.
Now the Professor Saeed Islam has moved to the another
Federation University, Melbourne. Federation.
Okay.
Ballarat University, former Ballarat University.
Okay. So so he is there now.
He is the Ballarat University Dean.
Okay.
Engineering Dean.
Oh, yes. So that's good. So he has moved the Curtin. I think few people came in and moved to from the Curtin.
Oh, Curtin fully changed. They chopped out one by one, couple of, to be honest. I should not say that on in this common platform. So far, you know the game here. Really difficult. Anyway, I think time mostly finished. So very nice talk with everyone and see the face. At least we're not physically close, but at least via Zoom.
Nice is good talking and seeing faces.
No, nice talking with you. And I'm very happy when I got your email today. I was doing another student's proposal. Oh, then I said, Professor Bansal sent email to me. Reply back to quickly. How can we connect?
Yeah, then I sent you another email that
you said Skype is okay. I'll just give me the time difference, then we will discuss sometimes.
Skype, like you can just see maybe I think few hours, maybe Melbourne, maybe, but you can.
So India, Melbourne 5.5. I don't know about UAE, maybe 8 hours.
Yeah, maybe you can just check it. Google maybe.
Okay, I'll do that one, and then sometimes my evening time we can have a chat.
Sure.
And discuss.
शाकिब जी आप फिजिकली आए हुए हैं या इधर मेरठ में या वहीं से बनारस में ही अभी?
नहीं, हम वाराणसी में ही हैं।
अच्छा, तो भारद्वाज जी के यहाँ आते हैं अभी मेरठ में? ये तो सब इन्होंने तो पार्टिसिपेंट को सब बुला दिया इधर ही।
हाँ,
बना दिया इन्होंने ऑनलाइन ऑफलाइन सब करके।
ये तो चाय से भी बच गए, चाय भी नहीं पिला पा रहे हैं हम लोग, बस वेट कर रहे हैं।
चाय बनाएंगे, इधर से डाउनलोड कीजिए आप चाय को।
बहुत अच्छा लगा।
यही टेक्नोलॉजी एक जो डिस्कवर होने वाली बची हुई है।
जी।
चाय को अपलोड कर दिया, उधर से डाउनलोड कर रहे हैं।
बिल्कुल। बहुत अच्छा लगा आपको देख करके और मुलाकात करके, काफी दिन हो गए थे। और
बिल्कुल टाइम गोज वेरी फास्ट।
हाँ, एक और हमारे यहाँ समस्या हो गई है कि IIT BHU में डायरेक्टर ने कहा है कि जो PhD एक्सपर्ट्स होंगे तो अरब कंट्रीज और विशेषकर अफ्रीकन कंट्रीज से मतलब नहीं देना है, ठीक है। तो मैंने पूछा कि ऐसा क्यों है? बोले कि यूरोपियन कंट्रीज, USA, UK, ऑस्ट्रेलिया, यहाँ से हम रिकमेंड करेंगे और कर रहा है, ठीक है ना। मैंने पूछा ऐसा क्यों है? मैंने कहा कि बहुत सारे एक्सपर्ट हैं जो अफ्रीकन कंट्रीज में हैं और अरब कंट्रीज में जो एक्सपर्ट मेंबर्स हैं, जिनके बराबर
उनको एक बार भेजिए उधर अफ्रीका में, then they will realize the importance of Africa.
Yeah.
The university I worked at University of Pretoria, गांधी जी की से पुरानी यूनिवर्सिटी है।
बिल्कुल
100 year, more than 100 years old.
हाँ।
So you can see कि the education system in South Africa is very old.
Yeah.
And good quality as well.
And finally, director is not recommending any expert from Arab countries and African countries.
कौन से डायरेक्टर कौन उनसे मिलके ही ना पर्सनली?
डायरेक्टर हम जाते हैं तो डर जाता है, यही तो समस्या है।
नहीं कहते एक बार आप लेके जाओ ना इधर, ये ओपन करके ये सब ना स्काइप कह जरा बात करो जरा।
दूसरा कर दिया है कि जो रिटायर्ड प्रोफेसर उनको नहीं टिक करना है, नहीं देना है। प्रोफेसर कोठारी को कई बार हमने बुलाया। अभी खुशखबरी है, प्रोफेसर कोठारी को नेशनल पावर सिस्टम कॉन्फ्रेंस में मालवीय अवार्ड दिया गया है 2020। मालवीय एक्सीलेंस अवार्ड
NPSC में।
हाँ एनपीएससी में।
एनपीएससी कौन सा था अभी? ये 2020 वाला भी है ना? कहाँ हुआ था अभी? गुवाहाटी?
हाँ होगा मेरे ख्याल से
है?
प्रोफेसर। हाँ अभी जो भी होगा, कब है डेट है उसका?
ये दिसंबर में होता है, मतलब अभी होने वाला होगा 1 आध वीक में।
हाँ है, आज इन्फॉर्मेशन प्रोफेसर कोठारी ने दिया है कि उन्हें मालवीय एक्सीलेंट अवार्ड पावर सिस्टम में जो हम लोगों ने इस्टेब्लिश किया था 2019 में।
तो मालवीय जी तो आपके यहाँ थे, उधर चले गए क्या एनपीएससी में?
नहीं ना ना ना, एक्चुअली क्या है कि जब हम लोगों ने
मालवीय तो आपके उधर भी तो है, जो मदन मोहन मालवीय, आपके यहाँ तो स्टेच्यू वगैरह सब लगे।
नहीं नहीं, एक्चुअली यह है कि जब हम लोगों ने 100 साल अभी सेलिब्रेट किया है 19 में।
अच्छा।
वी हैव सेलिब्रेटेड सेंटेनरी ईयर ऑफ एस्टेब्लिशमेंट ऑफ ITBHU। तो एडमिनिस्ट्रेशन ने मालवीय के नाम से एक अवार्ड स्थापित किया है ना, कि हर साल पावर सिस्टम इंजीनियरिंग में कोई एक्सीलेंट व्यक्ति होगा जो काम किया, तो हर साल एक अवार्ड दिया जाएगा ड्यूरिंग नेशनल पावर सिस्टम कॉन्फ्रेंस।
बहुत
ठीक है
बढ़िया
ना। तो अभी इस अवार्ड की स्थापना हुई है कुछ दिन पहले। तो प्रोफेसर कोठारी ने मेरे से कहा, तो मैंने कहा कि ठीक है रिकमेंडेशन देते हैं, और हेड से भी बोला। तो अभी आज की खबर है कि प्रोफेसर डीपी कोठारी को
तो आपके यहाँ से रिकमेंडेशन गया है क्या?
नहीं, ये IIT-BHU ने इस्टेब्लिश किया इस अवार्ड को मालवीय के नाम।
अच्छा, ये अवार्ड है उसका। ओके ओके। तो
हाँ,
ये
अवार्ड
मतलब कितने?
नहीं 100 साल जी, 100 साल पूरे हुए।
हाँ हाँ,
ठीक है ना। पिछले साल जब 100 साल पूरे हो गए, तो 100वें साल पर मालवीय के सम्मान में एक अवार्ड स्थापित किया गया।
तो अब ये
और
एनुअल रहेगा, बाई एनुअल रहेगा, कैसे रहेगा?
एनुअल रहेगा, प्रत्येक साल पावर सिस्टम कॉन्फ्रेंस में दिया जाएगा।
अच्छा, तो ये एनपीएससी 2 साल में होता है?
एनपीएससी हाँ 2 साल पे होता है।
फिर 1 साल गैप हो जाएगा, फिर किसको देंगे, फिर कैसे करेंगे?
फिर अब हमारे ऊपर, हम किसको दिला रहे हैं।
नहीं तो और किसी कॉन्फ्रेंस में दिलाएंगे?
ना ना ना, नेशनल पावर सिस्टम कॉन्फ्रेंस।
तो वो तो 2 साल में होती है ना।
तो जब भी होगी 2 साल 4 साल में।
मैचिंग नहीं करेगा ना फिर कि जब उसका पीछे एक...
नहीं तो 2 साल तो सर्च करना पड़ेगा ना कि किसको दिया जाना चाहिए।
और ये क्या नाम है इसका, एक पर्सन को ही देंगे आप?
केवल एक को देना है। यस जी,
5-10
अच्छा
लोगों को
किया।
तो दिला।
नहीं एक्चुअली ये इंस्टीट्यूट एक कमेटी है जिसमें मतलब मेन रोल तो इलेक्ट्रिकल डिपार्टमेंट का रहेगा।
नहीं मतलब एक ही, इट कैन बी मोर देन वन ना, एक बार में?
नहीं नहीं, एक ही अवार्ड रहेगा और नेशनल पावर सिस्टम कॉन्फ्रेंस में ही दिया जाएगा।
क्योंकि बहुत सारे पावर एक्सपर्ट हो गए बेचारे, काफी तो नंबर आएगा नहीं इस तरह से एक करके।
नहीं नहीं, अभी हम लोगों ने शुरू किया ऊपर से, जो पूरी जिंदगी कंट्रीब्यूट किया है और जो वर्तमान में कंट्रीब्यूट कर रहे हैं, जिन लोगों ने सारी जिंदगी कंट्रीब्यूट किया पावर सिस्टम इंजीनियरिंग को, उसको हम लोगों ने देना शुरू किया है। इसके बाद में जो अभी आप सभी लोग कर रहे हैं, तो उनको दिया जाएगा वेटिंग लिस्ट।
उनको भविष्य में दिया जाएगा जब ऊपर निकल जाएंगे।
बिल्कुल बिल्कुल। तो प्रोफेसर डीपी कोठारी को 2020 का मालवीय अवार्ड एक्सीलेंट इन पावर सिस्टम दिया गया।
चलिए, बहुत 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 अच्छा समाचार है। तो
जी जी जी,
सर को बहुत बहुत बधाई हो। सर ने बहुत सारे अवार्ड्स विन कर लिए।
हाँ हाँ हाँ, बहुत सारे अवार्ड उनके पास हैं। ठीक है प्रोफेसर भारद्वाज, चाय हम लोगों की कहाँ है?
सर अभी तक आपने वो टेक्नोलॉजी नहीं डेवलप की है, सिर्फ रेलवे का सिस्टम आपने डेवलप किया। चाय को तो डेवलप करिए, अगर कोई आपके यहाँ पे अपलोड कर दे तो आप उसे डाउनलोड कर पाए।
बिल्कुल प्रोफेसर,
टेक्नोलॉजी बताइए, मैं तैयार हूँ।
चलिए, सबसे बड़ी चाय यही है कि आपने हम सभी लोगों को इकट्ठा किया एंड हम लोग अब एक दूसरे को देख पा रहे हैं। और
मेरी कोशिश यही रहेगी कि मेरे जो गुरु हैं वो जरूर मेरे संपर्क में आते रहें।
बिल्कुल बिल्कुल, गुरुजी को तो इंडिया बुलाना है और गंगा स्नान कराना है। हरिद्वार से शुरू करेंगे।
बिल्कुल, हरिद्वार के लिए मैं तैयार बैठा हूँ, हरिद्वार के लिए।
हाँ, और बंगाल की चाय तक, मतलब वहाँ चाय खाने तक जाएंगे जहाँ तक गंगा जाती है समुद्र में, वहां
बिल्कुल, गंगा सागर
तक।
तो ये ऐसे बुलाएंगे कि पहले उधर आपकी तरफ होते हुए भारद्वाज जी,
हाँ जी,
और फिर इधर प्रयागराज होते हुए और फिर बनारस, और फिर आगे निकल जाए।
बनारस से विप्लव भट्टाचार्य के गांव भेज देते हैं, 24 परगना।
अभी तो बना, वो कहाँ है विप्लव? उधर ही है कि
IIT धनबाद में है।
धनबाद में? बात होती कभी?
But he's not feeling well at IIT ISM because he's not getting promotion. जो डायरेक्टर जाता है IIT कानपुर का जाता है तो कहता है कि इतना प्रोजेक्ट चाहिए, इतना पब्लिकेशन चाहिए, और पब्लिकेशन करते करते उसका VP बढ़ गया है. तो his VP is directly proportional to number of publications and he is not getting any promotion. वो जस्ट हमारे अप्लाई किया था IIT BHU में फैकल्टी पोजीशन के लिए.
अभी एसोसिएट है ना
जी,
अभी एसोसिएट है ना,
एसोसिएट है और काफी टेंशन में, उसका बीपी भी काफी परेशान कर रहा है इस समय. और टेंशन लेता, उसको मैं बोलता रहता हूँ टेंशन मत लो यार, प्रमोशन क्या करोगे.
So, Shweta madam is here with us. Ma'am, please announce.
Okay, sir. Thank you very much, sir. I once again, first of all, good morning to all the resource persons. Once again, I welcome all of you here in the day 3 session, second session of 6 days AICT sponsored this training, short-term training program on industrial automation and drives. I would like to first of all thanks Dr. R.K. Saket sir for being here throughout the session with us. And sir, definitely, you and like Narottam Das sir. So it is like our to boost our morale, just like that, sir. So thank you very much, sir, for being here. And now I request Dr. R.C. Bansal sir to please continue with the session. In this session, I would like to tell our participants that in this session, Dr. R.C. Bansal sir will cover automation and control of photovoltaic systems using power electronic applications. So, sir, please continue.
All right, so thank you all. So we are continuing. I hope everyone is able to hear about this MPPT. So this is a very, very important topic in the photovoltaic systems. Basically, how we increase the efficiency of the photovoltaic system. Then we discuss about briefly about the MPPT. Now we understand some more about the photovoltaic systems. Someone asked the questions about the deciding the rating, sizing, etc. So I will briefly discuss now. Now we talk about the rating, DC and AC power rating for the photovoltaic systems. Here, the grid connected system consists of an array of modules and power conditioning unit that includes inverter to convert the DC from PV into the AC required by the grid. When we have the photovoltaic system connected with the grid. So now we want to estimate the performance of the PV systems. So we have to compare the performance with respect of some standard test conditions. So the standard test conditions are generally like the 1 sun insolation, air mass ratio of 1.5, nominal cell temperature of 25 degrees centigrade. This we call the standard test conditions, because if you have to compare the performance of the PV systems in the different conditions or the PV systems from the different manufacturers, so we have to compare with respect of standard conditions. Okay. So when this PV system is placed in the field, the actual power delivered at 1 sun, called it PAC, can be represented as PAC will be equal to PDC under standard test condition multiplied by the conversion efficiency. So this PV system is having the power in DC, that how much power, AC power, it will feed into the grid. So it will involve the conversion efficiency. So this conversion efficiency is not only the efficiency of inverter, but it will have some other factors like for example, dust accumulated on the PV modules, the mismatching of the modules, and different ambient conditions. Okay. If we consider all these factors, so the conversion efficiency, if all these issues like the dust accumulated on the modules, mismatching of the modules, difference in the ambient condition, so this can lead to have the losses of the order of 20 to 40%. The conversion efficiency can be 90%, but in addition to the conversion efficiency, the other losses in terms of dust accumulated on the PV modules, mismatching of the modules, different ambient condition. So this can have the power losses, gross power losses of the order of 20 to 40%. Okay, now let us see what this mismatch of module is there. For example, we have the PV module. Okay, so it's the PV module. Say the PV panel, its rating is, for example, 180 watt. Okay, so if you have the PV module from one manufacturer, this 180 watt is at voltage of 30 volts and current of 6 amps. Then we can have the another module rated at 180 watt, but with a different current and voltage rating. So the another module, it can have 5 amps at 36 volts. Okay, both are having the 180 watt panel, but their voltage and current rating are different. Of course, their power rating are same. Okay, we may think that okay, we need the PV module of 180 watt. We want to have the extension, so we can have the from the different manufacturer. We think okay, power rating is same, so it will serve the purpose. But if their voltage and current rating are different, that's what we call as the mismatch of the module. So here, when we connect these two modules, each of 180 watt, but with different voltage and current ratings. Okay, so when these two modules are connected in parallel, we may think that the power which we may get 180 watt plus 180 watt, 360 watt, but that is not the case. If these two modules are connected in parallel, so instead of getting 360 watt, what we'll get is 330 watt. Why it is so? Basically, these two modules have one is having the current rating of 6 amps, another is having the 5 amps. The 6 amps is having the rated voltage 30. The 5 amps is having the rated voltage of 36. When these two are connected in parallel, you can see in the circuit, the total current contributed will be 6 plus 5, 11. But you will see that the voltage in parallel circuit will be same. So that voltage appearing across the module, it will be just 30 volts, not the 36. Okay, so 30 multiplied by current of 11, so that will give you power rating of 330 watt instead of giving the power rating of 360 watt. So we may need to keep this point in mind, that because of the mismatch of module, there can be efficiency loss of the order of 3 to 4%. So for example, if you have a PV array of 1 kilowatt under standard test conditions, so module nominal shell temperature is 47 degrees and 47 degree. The DC output at MPP drops 0.5% per degree centigrade above the standard test condition of 25 degrees centigrade. Estimate its output under PTC. So what is this PTC? Like it is similar to standard test condition, but in USA they have their own standard condition, what they call it PTC. So it stands for PV test condition in USA. Okay. So if you want to estimate the AC power output from this module, if there is 3% array loss due to mismatch of modules, as I explained you the mismatch due to the mismatch in the modules voltage and current stating, dirt loss is 4% and inverter efficiency is 90%. We want to see how much is the AC power output. Okay, so we as the engineer need to have the correct understanding of the AC power and DC power output. If, like for example, we want to install the PV system for our residential system, then if we go to the buy this PV system, so we need to have the understanding of the DC system and AC system, what DC systems we are installing, how much AC power we are going to get. So this example will be giving you some good understanding, nice explanation. So here, first, like we have to consider the PTC or STC condition to find the shell temperature. I'm not going into very detail of this example, but the basic idea is to explain that the what temperature you have got, what ambient temperature you have got, what is its impact on the efficiency. Okay, as a common person may think that if there is lot of sunshine, the weather is hot, we can generate more power from the PV system, but the situation is not like that. Okay, so here if the shell temperature is 47 degree, basically the ambient temperature NOCT, nominal operating shell temperature, is 47. The shell temperature will be 53.8. Okay, as the temperature of the shell PV module increases above the nominal temperature, it has more power losses. Its efficiency starts reducing because it is a semiconducting material. So the manufacturer will provide the data as well, that what is the nominal temperature. If temperature is more than that, then its power loss will start increasing. So you will see that because of this higher temperature, the DC power output from the PV module, okay, its power rating was 1 kilowatt. Okay, but because of the different shell temperature of the module, what we actually get, that there is power loss of 0.5% per degree above 25. So the actual shell temperature is 53. So because of that, the DC power what we will be getting from the PV module is 856 watt. Okay, then on the top of this, if we consider the another efficiency factors like the mismatch, dirt accumulated, inverter efficiency, if you multiply everything, with this factor. So the power output what we'll be getting from the PV module is 0.856 multiplied by the mismatch efficiency 0.97, efficiency loss because of the dirt 0.96 multiplied by the inverter efficiency. So overall AC power output we get from the 1 kilowatt DC module as 720 watts. Okay, so you can see 28% efficiency loss is taking place, although inverter efficiency is 90%. Okay, so this will give you very good understanding that what is the DC power and AC power rating of the PV module. Okay, because most of the load we are using is AC power, so we have to see. Of course, your PV module, its DC rating might be different, but what actually you get as the AC power, it will be significantly lower than its DC power rating. Now we want to decide the, for example, if you have grid connected system, it can be like the individual system, or it can be like a university buildings, or it can be some office. There is some good space available. One want to have the PV system for their own use, and the excess power it can be fed to the back into the grid. Now you want to decide the system sizing for the grid connected PV system. So how this system sizing will be decided. Okay. So when there is utility, you want to feed the power into the grid. So then you have to also think that whether the grid is quite reliable or you need some kind of backup. And of course, deciding the sizing of the grid connected system is not as critical as it is for the standalone system. I will explain about the standalone system as well. Here, the sizing of the grid connected system is more on the economical and some other aspects. Like for example, in the grid connected system, you want to see decide the its sizing, then of course you have to see how much is the area available on which you want to place the PV modules. If it is on the rooftops, how much space is available, and how much one would like to invest on this PV system. Now, of course, one has to know that the system sizing will require that how many units of electricity the utility is willing to buy. Okay, accordingly you will plan your PV system rating. Okay, so once you know how many units of electricity in a year the utility is willing to buy or have the agreement, accordingly you will plan that, okay, you have got this much of area available, then how much the rating of DC power will be required. So first, from the number of units required by the utility, and then to generate that much of electricity, how much space will be required, and then you can decide that this much AC power is required. From the AC power, you can convert back into the DC power rating. I give you example about the DC power and AC power rating. Okay, so but when you are designing in the actual system, Then you may need to consider some other aspects as well, that the certain sizes of the different systems, like your PV module, what sizes they are available, inverters, what sizing they are available, the battery systems, what specification sizing these are available. So you may need to consider these different aspects as well. Okay. When we have the standalone PV system, so the design for the standalone PV system is more critical in nature, because the standalone system, there is not grid supply, so you have to consider what type of backup it is going to be there. Okay, so backup is, of course, in terms of batteries. In addition to batteries, you can have the diesel generator as well as the backup. Now you have to make the decide about the system sizing for the PV system, standalone PV system. So how you are going to do that? First of all, since it is not grid connected system, you have to see where this PV system is being installed, how much is the load. Okay, so you have to make an estimate for the load. Your PV system, isolated PV system, it can be for some residential application, or it can be some office. So depending upon any type of your system is there, you have to make an estimate for the load. If, for example, it is the residential load, you may need to consider different kinds of loads, what will be placed on the PV systems, like the refrigerator, fridge. If it is, dishwasher is there, we have the toaster, microwave, TV is there, and air conditioning system is there. If it is like, nice house, then what are the other different types of loads, illumination, uh, computer load. So you make the estimate for the load. Okay, then once you have made the estimate of the load, then you have to also give a consideration about the diversity factor, diversity of the load, because whatever is the total load connected in the system, the whole load will not be supplied at the same time. When you see the load, you may have the air conditioning load, you may have the heater load, but you can see that heater and air conditioning system will not be operated at the same time. Okay. You may have the different light and power socket, but all the light and power socket will not be utilized at the same time. So means that the power system has got the diversity. So how the diversity is defined, that whatever the maximum connected load is there, and how much maximum load will be used at particular time. So that's how we define the diversity. Now you have to estimate the load, and you make the decision about the diversity. So depending upon different kinds of loads, like the residential, office, based on the similar load, an estimate can be made about the diversity as well. Okay, that will give you the estimate for the load, that this much maximum load is likely to be operated on the PV system. Then your design consideration for the standalone PV system will consider that first you have to make the estimate for the load that need to be served by the PV system. Okay, then when you are deciding the sizing of the PV system, then of course you have to decide the sizing of the batteries backup system. Okay, you have to decide the rating of the batteries backup system. Then you have to see how much load you want to use on your backup battery storage system or diesel generator. It is going to hold 100% load, or it is just going to be the minimum essential load, because the cost on the backup system will accordingly depend upon that. Okay, even we can give the consideration to the point that is part of the load can be DC. If that is the case, then we can improve the system performance, that the size of the inverter can be reduced, that all the power we need not to uh, change from DC to AC. Okay, so some of the efficiency improvement can be more made if we are using the DC load instead of AC. Is there DC load that can be used? Then we have to give the consideration to the point that what fraction of the full load will be supplied through the backup generator, that how much load will be supplied through the backup generator. Even your part of the load can be motor loads, like you can have small motors. So as you will see that motor will draw the large starting current, inrush current. So you have to give consideration to the inrush current as well. So you have to give the consideration for the different aspects when you are designing the standalone photovoltaic system. Now, in the battery is the most important aspect in the renewable applications, and there are applications in future. Electric vehicles are likely to come, so the battery is extremely important in recent time, particularly in the renewable applications. So these batteries in the PV system provide the storage or backup systems. So here there is a lot of interest in the batteries technology. There are a lot of options available for the batteries. Which one is best will depend upon the situation, and we need to give the consideration for large number of factors, technical and others, in terms of like the cost, weight of the batteries, number and depth of the discharge, efficiency, temperature, charging and discharging rates. So depending upon application of the batteries, if it is being used in the renewable systems, electric vehicles, or some other applications, so you have to give consideration to the number of technical and non-technical parameters. First of all, for any application for which battery is being used, you have to meet the technical requirement from the batteries. You can have the different possible options available from the batteries that you want to consider. It can be lead acid, nickel metal, hydride, lithium ion, etc. Then you have to give the consideration to that different technical aspects that the battery you select should fulfill those requirements. These requirements can be in terms of what is the power density, in terms the energy density, that watt hour per kg. So this, what is the density? Means the battery size will be compact while considering this aspect. Then with the different battery options available, you have to consider that how much is the cost for the different options, because economy is very important. You have to consider the cost options. Then you have to consider the uh, like how many charging and discharging cycle battery can afford. So basically it will decide about the life of the battery. Then how much time the battery will take for the charging and discharging. So this is important, particularly like in the applications like in the electric vehicles. So you have to give consideration for the charging times, and what is this power density of the batteries. So you can see that for selection of proper type of battery, you have to give consideration for the large number of technical and other factors to make the suitable choice for the battery. Now, when you are integrating the PV systems in the grid, depending upon the size of the photovoltaic system, whether the photovoltaic system is small, residential systems, you are connecting in the distribution system, or your PV systems can be a very large system like a PV plant, PV farm. So that can be integrated in the transmission system. So depending upon the size of the PV system, whether it is being installed in the distribution system or in the transmission system, technical challenge and issues are different. For example, when you are integrating PV system in the distribution system, so here the issues, like for example, moving cloud. So it can affect the performance of the PV system. So you consider the issues like the moving clouds. Or if the significant PV system is integrated in a particular city or suburb, okay, so how it can affect the performance of the PV system. It can affect the performance of the distribution system. For example, during midday in the residential system, power requirement will be minimum as people go to work, students go for their study. So during midday in the residential system, power requirement is the minimum, whereas the power produced from the photovoltaic system is maximum. So that can lead to have the situation of voltage and frequency regulations. There can be some other uh, power issues in terms of over and underloading of the feeders and so on. So in the distribution system, you might be interested in studying this kind of issues. Now, when we are talking about the large size photovoltaic systems, that if the PV system is installed in the transmission or sub-transmission system, PV system is very large. Okay, so when the PV system is very large, so what kind of technical issues you may need to consider. Here, the issues like the moving clouds is not significant because the PV plant will be spread over the large geographical area. Okay, so in that case, you will be interested in knowing that how the PV plant can affect the overall stability of the system. As you see that PV system has got no moving parts, whereas other types of plant like the coal-based power plant, gas-based power plant, nuclear power plant, large hydro, they have got the generator, synchronous generator. So the kinetic energy is stored when the generators are rotating. So the kinetic energy stored in the generator helps in making the system stable. But when these synchronous generators are replaced by the photovoltaic systems of the significant size, so in that case, overall stability of the power system can be reduced. So when the size of the photovoltaic system is significant, then we need to consider that how the overall stability of the PV system is going to be affected. So we study the effect of for the large photovoltaic system, we studied the effect of the stability on the system. Stability could be in terms of voltage stability, small signal stability, etc. So I'm not going into detail of that, or it can be frequency stability as well. Now, grid code of operation. As I mentioned that, when these renewables are integrated with the grid, so certain grid codes have to be followed so that independent power producers may not pollute the quality of power. So here, the standard IEEE 1547. So this standard was adopted for the PV systems up to the rating of like the 10 MVA. So this is basically a small size PV system. But now we are coming up with this like the large PV plants in the range of 100 megawatt or even more. So this standard IEEE 1547, which may not be applicable because this is a standard applicable for the small size PV systems. So several countries, like for example, Germany, Spain, they have developed their own grid codes for the large scale PV integration, and some other countries like China, Italy, they are developing their own grid codes for the large scale integration. Okay, now the one of the point I would like to mention that about the control, automation and control from the PV system, because this is one of the theme of this short term, that if you have this PV system, what kind of automation and control we have when we're talking about the small scale PV system or large scale PV system. So the control I mentioned is mainly about the reactive power and voltage control. So when we used to have the small scale PV system, the small scale PV system will operate and design for the unity power factor. But for the large scale PV system, as you can see in the last bullet point, For example, according to German code, PV plants should be capable of providing the reactive power at the point of interconnection in the boundary of plus minus 0.9 power factor. What does it mean? That these PV plants will not operate at the unity power factor, but they should operate with plus minus 0.95 power factor. What does it mean? That this PV plant, they are operating in leading or lagging power factor mode. It means that PV plant can supply or absorb the reactive power depending upon the requirement. So the modern large size PV plants, they will not simply operate at the unity power factor, but they can control the reactive power. And controlling of reactive power means that they can manage the voltage of the grid connected system. So if there is fault on the grid connected system, obviously the voltage will drop. When we have these PV systems with leading or lagging power factor, so they can control the reactive power during the fault condition. During the fault condition, voltage dips, so this PV plant can supply the reactive power, and then they can improve the voltage profile of the system. So obviously this PV module, when fault is there on the system, so the past approach was that the PV plants will be immediately disconnected, but now with the modern plants, so they will not be immediately disconnected, but they will help in recovering during the fault conditions. Okay, now let me give you the quick overview of the installed capacity of the photovoltaic systems worldwide, what we have. The worldwide installed capacity of the PV system, you can see currently we may have the installed capacity last year around 630 gigawatt, but end of this year we may expect that this PV installed capacity worldwide, it can reach around 800 gigawatt. Okay, so how the installed capacity from the PV system worldwide is increasing. So you can see this is increasing exponentially. Every year, if you see the capacity addition, you can see typically it is 30%, 30%. So means that in around 3 years, the capacity addition worldwide, it will be just doubled. So you can see that PV in recent time is very popular, and lot of capacity addition is taking place worldwide. So recent past, the cost used to be one of the major issue, but that cost is no more an issue and technology is quite mature, and the significant capacity addition is taking place worldwide. If you see some of the top countries who have the significant capacity from the photovoltaic systems, of course China, followed by US, Japan, Germany, and then of course our Indian system really doing great. Then other countries like Italy, UK, Australia, so they are also having the significant power generation from the photovoltaic systems. So this slide I prepared few years earlier. You can see around 2014-15, there were several PV plants worldwide in the range of like 500 megawatt, or several PV systems more than 100 megawatt. They were either in operation or in construction. But if you see some of very recent updates. So you can see that there are several plants of significant capacity, like for example, in Egypt, 1.8 gigawatt means 1800 megawatt PV plant is under construction. So if we like this 2000 megawatt plant, we call it like the super thermal, like this coal-based plant. If we say that any plant is rated 2000 megawatt, we call it like super thermal power plant. So the PV plants are coming like, size of the conventional power plants. So 1.8 gigawatt in Egypt under construction. China has 1547 megawatt plant. Then there are several other plants like in USA, Mexico, Brazil, UAE, in the range of 500 to 800 megawatt. Now let us see some update about our Indian photovoltaic systems. So last year, we in Karnataka constructed a PV systems of the rating over 2000 megawatt. It costed around 15,000 crores, and the plant is spread over the area of about 50 square kilometer. Okay, we have other plants like in the Rajasthan, Bhadla solar plant. So the capacity of again over the 2000 megawatt. Then in addition, that we know that NTPC, National Thermal Power Corporation, which is the utility main business in the power generation from the coal and gas-based power plants, have got more than 20 power stations spread all over India. I visited large number of their plants. So they are diversifying their business, moving from only coal and gas to renewables as well. So they are planning to have significant investment in the renewables, targeting to have the 32 gigawatt, means 32,000 megawatt in the renewables in the next 10 years. So basically, they want to have their energy mix, which is currently 96%. So currently, most of the power they are generating is from the coal or gas-based. So they want to diversify their portfolio from the existing 96% to bring down to 70%. Means like 70% from fossil fuels, then 30% from the renewables. So they want to have diversify their portfolio significant in the renewables. This is again very interesting slide. You can see that this is the system. I worked at the University of Queensland in Australia a few years earlier. So at that time, we used to have 1.2 megawatt PV system at the University of Queensland. At that time, it used to be the largest size of PV system in the Australia. But now, of course, there are several other large PV plants. And now the capacity of this plant has been significantly increased. The great part of that is that through this website, in the real time, so for example, today, now you want to see how much generation it has taken place. So through this website, in real-time system, you can see this graph. So it will give you the nature of graph, how the generation it took place today in real-time system. You can see how much the total energy it has produced since its installation, how much saving this plant has made. In addition to that, you can find several other interesting information, practical information, that what kind of PV modules are there, what kind of battery storage system is there, what kind of inverters is there, whether the PV module is fixed mounted or there is single axis or two axis tracking systems. So you can find lot of practical information. For example, you want to plan, for example, your university, you want to have, say, for example, 100 kilowatt, 200 kilowatt uh, photovoltaic system. So you want to get some information, what kind of PV module options are there, battery, what kind of options are there. So you can find lot of practical information, their performance. So you can find lot of uh, interesting information. So anyone interested in knowing more about the design or selection of the components, batteries, inverters. So you can find lot of interesting information. Anyone who is interested more knowing about the about some large scale PV system, know more about the stability of the system. So you can refer first a review paper. I think we are about to end of this session. So we are just uh, finishing the uh, PV part. So this I have covered. So I'll just try to explain one very important point. When we have the photovoltaic system which is connected with the grid, and this is common questions, it will come in our mind, that if the PV system is connected with the grid, whether we should have storage system or not. If the storage system is there, will it be beneficial? Which way it is beneficial? Of course, when we have these PV systems with storage system connected to the grid, it will increase the cost. But which way it can be beneficial? We are aware of the daily demand load on the PV system. Then if you have these PV systems of the significant sizing with the significant capacity of the storage system, so this PV system can help the utility in maintaining their load profile flat when there is peak demand on the system. So the PV system with the battery storage system can help the utility in maintaining their demand profile flat. For example, during evening, there is peak demand on the system. Okay, so the energy stored in the batteries can supply the power to the utility. It can help the utility in maintaining their demand profile flat. So uh, this is, I think we have still some time, or Dr. Bhardwaj, or
We are having maximum 5 to 7 minutes.
yeah, so maybe I will just stop. Maybe for the two sessions, I will be more than happy to take more questions.
Right, sir. So one question from one student.
Yes, please.
He is asking, sir, why voltage is 30 volt? Why not 36 volt?
Yeah, this is good questions. Let me go to this slide. This is, for example, what we call as the mismatch of modules. For example, you installed a PV system maybe on rooftops, can be for the house or maybe university. You made the your system, but then later you realize that okay, your load is increasing. You want to add, increase the capacity.
Right.
Now, previously you might have taken the PV modules from one manufacturer. Then after 5 or 10 years, you want to find whether the same manufacturer is available or not. So you see that that is not there, then you have to find some alternative. Then you will try to see, okay, let me try to find the same power rating. Of course, the PU modules are this previously were the 180 watt. Now you can find in the market there are modules of 180 watt. They say, okay, yes, we have available. But if you are engineer, you'll know that the only matching the power rating is not sufficient. You have to see that its voltage and current rating should also match. Okay. The previous modules you may have, it may have the the modules with the current rating of 6 amps with the voltage rating of 30. So it gives you power rating, which is voltage multiplied by current, as 6 into 30, 180 watt. But now if you find the module with the same power rating, 180 watt, but say, sometime you go with the manufacturer, shopkeeper, they will say, नहीं सर बिल्कुल सही है, ठीक है, ये सही, आप ले लीजिए, कोई चिंता नहीं कीजिए, सेम पावर रेटिंग बिल्कुल फिट काम करेगा. But if you are a technical person, you will understand that it is not only the power rating, but you have to see the current and voltage. Okay, so the new modules power rating is same, but it is having the rated 5 amps and 36 volts. Again, 5 into 36, it is making 180. When you connected these two modules in parallel, so in the circuit you can see the total current will be summation of the current in the parallel circuit. 5 and 6, it makes the 11. Current, there is no issue. But the rating of one module is 30, another is 36. So your voltage, which is minimum, will be there. Okay, so your overall power which you will be getting is 30 multiplied by 11 will give you 330 instead of 360. So this is what we call as the mismatching.
Right. Correct. And another,
even the question student ask, like if you want to see corresponding to this graph, if you are considering corresponding to 36, then even you may end up with 280 watt, because here you see corresponding to that the current will be 8 contributed 8. It can give you even still lower, that is 280 watt. This is what we call as the mismatch.
right. And another, the older question, how we decide the size and rating of the battery for a PV cell? It is still continuing.
Okay, so is it for the grid connected or isolated system, please?
Grid connected.
Yeah, grid connected system, deciding the battery sizing.
Battery charging. Correct.
Yes, so battery, first of all, even we have to see whether we want to keep the batteries or not. Because, in the grid connect system, if the grid is very reliable, we may not require the battery system. If we are adding the batteries, of course, the cost, it will increase. I give the example that it can have some additional benefit, like help in maintaining the profile flat. Then of course you have to see that this is very interesting question. In fact, uh, that you have to see that how much backup you wanted. Okay, you have to see the situation for how many hours of the backup you wanted. Generally, you have to see how much grid is reliable. If the grid power supply fails, then for how many hours you want to have the backup. And if you want to have backup, which how much load it is going to be supplied through batteries. Like whether you are going to supply the almost whole load, or you are just going to consider supplying of the essential load. Essential load could be just like your lighting loads. You can have, maybe some fans, or you want to have the full luxury, like you will operate the air conditioning system, you want to operate the lifts as well. So you have to decide, if you are operating full load, then of course you are, you know, how much load you can operate with the battery, it will be just last for few less hours.
Correct. Now, next, Professor Ashok Rajput want to ask some question. Professor Rajput, you ask.
Okay, sir. Okay, sir. Sir, good afternoon, sir. I am audible, sir?
No, sound is very much less. You speak loudly.
Okay. I am audible, sir. Good afternoon, sir.
भारद्वाज जी, आपको सुनाई पड़ रहा है?
हाँ, मुझे सुनाई पड़ रहा है।
तो आप सुन के फिर इनडायरेक्ट कर दीजिए, आप दोबारा बोल दीजिए मुझे, आई कैन नॉट हियर.
Okay, okay, sir. My question is, sir, what factor affecting the performance of PV system, sir?
What factor effectively performance on the PV system?
Yeah, so basically the factors you will see that, first of course, where we are installing the PV system, first you have to see about the insolation level. Then, as I mentioned, the ambient temperature. If the ambient temperature is very high, shell temperature will be high, the power output from the PV module will start decreasing. So ambient temperature is like one of the major issue. Then we have to regularly keep up cleaning of the PV module. The dust is accumulated. If the dust is accumulated on the module, some efficiency loss will be taking place. Okay. Then the other devices like your inverter's efficiency, your batteries efficiency, then your, if the system has MPPT or not. So there are the different factors which will give you overall. And as I did not explain, but as you know, the efficiency of the PV system, of course, there is no moving part. There is direct conversion from the electricity. Still, the efficiency of the PV system is very low, typically around 15%. Of course, if you have a larger efficiency is always beneficial. But here we are not using any fuel, so it is not a big concern. If the efficiency of coal-based power plant is low, this is really a concern, because we are burning coal means we are burning money. Here at least sunshine is there, so which is free. So efficiency is high, it is good. But if low, so it is not like the major concern as we have in the coal-based system.
But Professor Bansal, one important point in the solar system that there is a dusting.
Dust, yes, sir. Dust is very important. That it's not that you have PV panel and just left and you are not bothered to clean it for several days. So this is very important that as per recommended procedure, the PV module should be cleaned to give you more output.
One question from our student Abhi Singh. That will ask Abhi Singh. Abhi Singh, you can ask the question now. Abhi Singh, ask the question. Unmute your system.
Hello.
Hello. Yes, please.
Yes, sir. Yes, sir. Sir, I want to know what is the effect of PV panel temperature. Like it has very low efficiency, about 15-20%. So most of the energy which is coming from sun rays is wasted in heat, and which increases the temperature of the PV panel.
Speak loudly, please.
Sir,
can you increase
I am asking.
Sir,
I am asking that only small percent of energy which is coming from sun rays is converted into electrical energy, and rest is wasted into heat energy, which increases the surface temperature of PV panel. So, sir, how it affects the efficiency? Like with temperature increase, that efficiency drops with time.
Yeah, so basically is very good question. In fact, like, let me show you the example I explained. Even like, for example, the rating of the PV module, say for example 1 kilowatt, if you have the quite summer weather, if the nominal temperature is quite high, or if you have the spring season that the nominal temperature is around 25 degree. So during hot summer, lot of power will be wasted as the heat. So we have to keep in mind that, common people will think that, okay, if it is hot summer, it will produce more power, but it is not the case, because for power to be produced, there basically weather should be clear and sunshine should be there, but it should not be very high temperature. So basically, the significant power is being wasted as the heat.
What is the level of temperature is required to get maximum power from the PV system?
Yeah, just basically you can see if the PV module, its temperature is around ambient, around 20 or 25.
Right,
So
right.
if the nominal temperature is 20, 25, so that will be the good temperature for to produce more power from the PV module.
Correct.
And sir, hello sir.
Yeah. Speak.
Sir, like we cannot avoid the increase in temperature of the solar panel. So what are the techniques we can use to reduce it? Like I read there was, thermoelectric coolers were using and are in research. They can be used for cooling, and phase change materials are using for reducing the temperature of the panels.
Yeah, so thanks very much for very interesting question. In fact, when we have the small scale, small size, we can find that some approach which we can use to maintain the temperature of the PV module around nominal temperature. Even for the large size PV plant, the options are being find that can we have the installation of PV module like in the sea. Okay, because area is also one of the concern, where the PV module will be placed. So even if the PV modules can be placed in the sea, so that sort of operations are explored and researched. So basically, it is still ongoing research. People have not explored much about because even when we are in UAE here, temperature is huge, but still not some good options have been tried or worked out. But hopefully, as the technology uh, enhances, so hopefully some solution may be come out in future.
Correct. Are we seeing any question from your side?
No, sir. No, sir. Or
So thank you very much, Professor Bansal, for this question time.
So I hope my session is completed for today.
Yes.
Okay, so thank you very much, Dr. Bhardwaj and all the participants. It has been great. Very nice talking with you, Professor Saket. So I look forward to continue. For now, I have session on
Sir,
18th.
Professor Bansal, I have one doubt, sir.
Yes, please.
May I ask one question?
Professor Saket?
Yeah.
First, you can switch your camera.
No. I don't want to switch my camera. Just I would like to ask one query.
Yes, please.
What is difference between system stability and reliability? Because actually, I would like to provide two different statements. Your life is stable, means your life is 100% stable. Is it clear? And the second question is your life is 100% reliable. Okay, so actually we are interested to know about difference between systems reliability and stability, because both are important aspect of power system engineering.
I can interfere, Professor Saket. You are the reliability. Then you are asking the question to Professor Bansal this.
Yes, some of the parts I left to Dr. Saket, to you. This type of difficult questions,
Okay, thank you very much. I would like to discuss in detail in my session.
Yeah. Sure.
Madam Shukla, please conclude the session.
All the best. See you on 18th.
Okay, sir, thank you very much for such a nice and informative session. And we are really highly privileged to have you here. And we are looking forward for the next session with you.
Sure.
So, sir,
Dr. Bhardwaj, I have sent you this morning the slides.
Okay, sir. Okay.
So all the slides I have sent you.
I will check.
Thank you very much. All the best.
Thank you very much, sir. And thanks to all the participants and our honorable guest here, Dr. Saket, sir, and Narottam Das, sir. Thank you very much, everyone, sir. For participants, I would like to say that our next session will start at 1:45 p.m. So we are having a break, 1 hour break, and after that we'll start with our next session. Thank you very much, everyone.
Thank you, sir. Lot of thanks.
Thank you. Thank you.